Hello everyone, this is Mr. Lim again. So we have already learned the composite function and the inverse function, and we have already solved some problems related to composite and inverse function. Now we need to learn more of an inverse function. All right. So suppose you have a function called fx, and fx is equal to 2x squared minus 5x plus 1. And I want you to sketch fx. Okay. Um, you have already learned from quadratic function that if you want to sketch fx, because fx is a quadratic function, right? Fx is a quadratic function. You want to sketch fx, you need to identify the stationary point. And for quadratic function, to find the stationary point, you can use differentiation or you can use the completing square method. So in this case, we use completing square method to determine the stationary point. So before I sketch fx, I need to identify the um, fx in completing square form. So fx equal to 2 bracket x plus b over 2a close bracket squared plus c is 1 minus b squared over 4 times 2. That's the formula, right? So I got 2x minus, this is negative 5 over 4 squared, and then this I get 1 minus 25 over 8. So I get 2x minus 5 over 4 squared. How much is this? 1 minus 25 over 8. 25 over 8. I get 17, negative 17 over 8. So this is the completing square form. And from here, I know that the curve consists of a minimum point, and this minimum point is located at coordinate 504 and negative 17 over 8. So I can sketch this function already with the information. So this is my y-axis and this is my x-axis. Y, x. So I have 504 here, and then I have say my negative 17 over 8 is here. So this is a quadratic graph. um Sorry, maybe I should move this to the side a bit, move 504 to the side a bit, huh? Okay, so let me erase this one. Okay, so I get here. Right. So this is my 504 and this is my y-intercept 1. Okay, so this is fx. I've sketched fx already. So this is my first question. And second question is state with a reason whether the inverse of f exit. Please be very careful. This question doesn't ask you to find the inverse, right? The question doesn't say find the inverse. It just asks you to state with a reason whether the inverse exists. So how do we know whether the inverse exists or not without finding it? We need to apply the horizontal line test. What is horizontal line test? Horizontal line test is, okay, we have a horizontal line, and then I will move this line up and down from a graph. Okay, I move the line up and down from a graph, and take note, whether the horizontal line intersect the graph once or more than once. So from here, I can see that the intersection of the red line and the black curve is always 2 times, right? So there are 2 intersection point, 2 intersection point, and so on, and so on, and so on, and so on. Only here, the minimum point, there is only 1 intersection. So in general, I have more than 1 intersection. So if more than 1 intersection, it means the inverse doesn't exist. So how to write? So the answer is, since fx is not 1 to 1 function. 1 to 1 function means the intersection must be only once. As you can see, we have 2 intersections. All right, as you move the line up and down, the intersection always more than once. All right, so it is not 1 to 1 function. Okay, so if it is not a 1 to 1 function, then the f inverse does not exist. Okay, so by applying horizontal line test, if the intersection of the curve with the horizontal line is greater than 1, this will imply that not 1 to 1. So not 1 to 1, the result is the inverse does not exist. Okay? All right. So next, let's try this question. Okay, let's try this question. I should, yeah. All right. This question is from the slide. Okay, this question is from the slide. Let me remove this one. Okay. As you can see from here, all the functions here are all the functions here consist of an inverse, right? How do I know? Because if I apply horizontal line test, okay, I apply horizontal line test. Let me make this transparent. Okay, if I apply horizontal line test and move up and down, I can see that the intersection of fx and my horizontal line is always once, right? So only 1 intersection point if I move up and down. The same for this one, right? The intersection always once. Okay, so since I know already the inverse exit, all right? So maybe we can write a conclusion here. Fx exit because they are 1 to 1 function. Okay, so we know that the fx exit. So what's the question one? The question wants us to sketch the inverse function. Oh my god, how to find the inverse function? Because I don't have the equation, right? So it's very easy. First of all, you need to construct a line, and this line is the y equal to x line. All right. So in order to find the inverse graph, you need to sketch this line first. Okay, y equal to x. Okay, without finding the inverse function, actually we can sketch the inverse curve by just the information of fx. Okay, so now how the inverse function looks like. So the inverse function is a mirror image of this one. Okay, so it's a reflection. So we can see from here, it touches this point. So this point is located at 4, 2, right? 4, 2. So the reflection point will be located at 2, 4. So it is here. All right. Okay. And for fx, this is the asymptote. The y-axis is the asymptote. So reflect through y equal to x line. Now x become the asymptote. Okay. So again, it passes through 1. So this is the asymptote, right? So the graph of inverse look like this. Oh, no. I should draw nicer. So it should be like this. Yep. So this is my F inverse curve. Okay. So the same for this one. So how the inverse curve looks like. So as I can see, this coordinate is 6, -2. So it will reflect at -2 and 6 here. Okay. All right. And then this is the intersection point. So I can straight away draw the line. Yep. Yep. So this purple line is the inverse line. Okay. So this chapter is a little bit complicated. So if you have any other question, please do not hesitate to make appointment with your lecturers to clear your doubt. Okay. Thank you very much. Bye-bye.